when it comes to integration, it may not be immediately obvious where to start. This does become a lot easier the more you practice, the more examples you actually do. There are various techniques, and as I said, when the first time you look at an integration problem, it may not be immediately obvious how to start. Um, one technique is to see if we can find the derivative of one of these functions. So for x squared, we, for example, call f, and e to the x cubed, we call g. If we can take one of these functions, differentiate it, and it gives us the form of the other function, then that is a clear u substitution. Right, so that's what we're going to do here. So if we let f of x be x squared, g of x be e to the x cubed. If we take the derivative of g to the x, of g of x rather, so g prime x, the derivative will be the function itself, e to the x cubed, and using the chain rule, we multiply by the derivative of x cubed, which is 3x squared. So just writing this in a better way, 3x squared e to the x cubed. So we will have, if we let u equal x cubed, then when we differentiate, this du will equal 3x squared dx. So we've got the x squared here, which is going to cancel out with this x squared over here. Well, that's going to clean up this integral very nicely. So we'll have the integral of x squared. We have x cubed is u, so it's going to be e to the u, and then dx will be du divided by 3x squared. So dx, we are going to write this as du over 3x squared. So we've got the variable u and the du. The x squared is now going to cancel with the x squared. So there's only one variable in this integral. So we have the integral of e to the u divided by 3 du. We can take the third out because it's a constant value. So we'll have the third times the integral of e to the u du. Okay, so that equals the third. The integral of e to the u is the function itself again. So we'll have e to the u, and we have to add the constant of integration plus c. That's not the final answer because we did use a u substitution here. So it equals a third. E to the u we called x cubed. E to the x cubed plus c. You can leave it like that. Alternatively, you can bring the third into the brackets. A third e to the x cubed, and third times the arbitrary constant is just another arbitrary constant. You can call it a, b, whatever it is. You can call it c again if you like. So this will be the final answer. So here we have x, we'll call that f of x, and the square root of 1 minus x squared, we'll call that g. So if we let u equal 1 minus x squared, then du equals minus 2x dx. So that will give us the integral of x times the square root of u times dx. Dx will be du divided by minus 2x. So dx will be du divided by minus 2x. The x is not cancelled, which is nice, which is what we're looking for. And we'll have the integral of the square root of u divided by minus 2 du. You can take minus 2 out, minus a half out as a constant. So we have minus a half times the integral of, and root u, we're just going to write as u to the half du. So that will equal minus a half. The integral of u to the half, we're going to add, this is the power rule, so we're going to add 1 to that. So we're going to add 2 over 2. So that will give us u to the 3 divided by 2. And then we divide by 3 divided by 2, which is really the same as multiplying by 2 divided by 3. And we can add a constant of integration. So this will give us minus a half times 2/3 will be minus a third u to the 3 over 2 minus a half times the arbitrary constant c. It's just another arbitrary constant, so we'll just keep it as c. You can call it whatever you want, but it really doesn't make a difference because it is an arbitrary constant. When you differentiate a constant, the derivative of a constant is always going to be 0. So it's irrelevant what you call this constant here. Just remember that we called u, we let u be 1 minus x squared. So it's minus a third times 1 minus x squared to the 3 over 2 plus c. And if you like, because the question was given to you as a surd, you can write this in a neater form if you want to. You don't have to. This will be the square root of 1 minus x squared cubed plus c. Here we are going to let u equal 3x minus 2. Therefore du equals 3 dx. So this will equal the integral of u to the 20 times dx, which is du divided by 3. You can take the third out because it's a constant, so it's a third times the integral of u to the 20 du. And when we integrate u to the 20, we add 1, so we'll have u to the 21, and we then divide by this new exponent, 21, and we add the arbitrary constant c. So that will equal the third times 1 over 21 will be 1 over 63 u to the 21 plus c. And remember that u is 3x minus 2, so this is 1 over 63 times 3x minus 2 to the 21 plus c, and that is the answer. Okay, here we're going to use the substitution. U equals pi t over 2. So du equals anything that is not t, or any form of t, is a constant, right? So pi over 2 is a constant, and the derivative of t is 1. 1 times pi over 2 is pi over 2, so du is pi over 2 dt. So we now have the integral of cos u, and dt will be 2 du divided by pi. So we'll have 2 du divided by pi. So 2 over pi is a constant, so we can pull that out of the integration, and we have 2 over pi times the integral of cos u du. Integral of cos u is sine u. The derivative of sine is cos, so the integral of cos is sine. So we have 2 over pi times sine u plus the arbitrary constant c. So it's 2 over pi sine u plus 2 over pi times arbitrary constant is just another arbitrary constant, so we can just call it c again. And just remember that u is pi t over 2. So the final answer is 2 over pi sine pi t divided by 2 plus c. Okay, here we are going to let u equal 1 minus e to the x. The derivative du with respect to x. So du equals minus e to the x dx. So this will equal the integral of e to the x over u squared, and dx equal du over minus e to the x. So it will be multiplied by du over minus e to the x. E to the x cancels, which is nice. So we'll have the integral of minus 1 over u squared du. You can pull the minus 1 out, so it's minus the integral of u to the minus 2 du. That equals minus times. We can add 1, so we'll have u to the minus 1, and then we divide by a minus 1. So we're just going to put the minus in front. This is neater. And we add the integration constant. So we will have minus times minus. We're just going to have u to the minus 1 plus the arbitrary constant. So that's going to be 1 over u plus c, and u we called 1 minus e to the x. So the final answer is 1 over 1 minus e to the x plus c. Okay, here we're going to call ln x, we're going to call u, or ln x, however you want to say it. Du equals, the derivative of ln x is 1 over x, so du is 1 over x dx. So that'll give us the integral of u squared over x dx will equal x du. So dx is x du, the x's cancel, which is nice. So we have the integral of u squared du. The integral of u squared, we're going to add 1 to 2, so we'll have u to the 2 plus 1 is u to the 3, and then we divide by 3 and add the arbitrary constant. So that equals a third. U is ln x, so it's going to be a third ln x cubed plus c. Here we are going to call u 1 plus e to the x. Du therefore equals e to the x dx. So we have the integral of e to the x times the square root of u times dx. So dx would be du divided by e to the x. So we have du divided by e to the x. E to the x cancels. And we're left with the integral of root u du. So it's the integral of u to the half du. So when we integrate u to the half, we're going to add 1 or 2 over 2 to our half. So we'll have u to the 3 over 2. And we divide by 3 over 2, which is the same as multiplying by 2/3. So we're going to multiply by 2/3 and add the integration constant. Just remember that u is 1 plus e to the x, so it's 2/3 times 1 plus e to the x to the power of 3 over 2 plus c. Now this one may look more complicated than it actually is. Just look a little closer. If you look at x cubed, if you just call x squared plus 1f and x cubed plus 3xg, don't worry about the 4 here. If we take the derivative of g, we'll have 3x squared plus 3, right? So if we call g of x x cubed plus 3x, then the derivative of g will be 3x squared plus 3. And if we take out a common 3, we have 3 times x squared plus 1. And that's the function f, the x squared plus 1. So again, we're going to use the u sub. So u equals x cubed plus 3x. So du will be 3x squared plus 3 dx. And we're going to take out the 3. 3 times x squared plus 1 dx. So that will be du. So we have the integral of x squared plus 1, x cubed plus 3x is u. So we have u to the 4. And then dx is du over 3 times x squared plus 1. So du over 3 times x squared plus 1, and the x squared plus 1 brackets cancel out. So we are left with u to the 4 divided by 3. So just write it like that. U to the 4 divided by 3 du. You can take the third out rather, and the third times the integral of u to the 4 du. So when you integrate that, we'll have a third times the integral of u to the 4 will be u to the 4 plus 1, so it'll be u to the 5, and we divide by 5, and then add the arbitrary constant. So the final answer, well, not the final answer, but we'll have 1 over 15 u to the 5 plus the third times c again is just going to be another c, another constant, arbitrary constant, and u we said was x cubed plus 3x, and that's to the power of 5 plus c, and that is the final answer. Okay, looking at this, you might not know where to start. It's imperative that you do know your standard integrals, right? You'll have a table of integrals that you'll need to be familiar with. The integral of 1 over 1 plus x squared will give you arctan x. So if we look at this, we've just write this in a different way. 1 over 1 plus x squared, so it'll be 1 over x squared plus 1, 1 over 1 plus x squared, times arc tan x squared dx. So if we let u equal arc tan x, then du, the derivative of arc tan x is 1 over 1 plus x squared, and that'll be dx. The integral, if the integral of 1 over 1 plus x squared is arc tan x, then the derivative of arc tan x is 1 over 1 plus x squared. So we have the integral of 1 over 1 plus x squared. Arc tan x is u, so we have u squared, and then dx will be 1 plus x squared times du, and then divided by 1. So it's just 1 plus x squared times du. So dx will be 1 plus x squared times du. The 1 plus x squared will cancel with the 1 plus x squared, so we have the integral of u squared du, and that'll give us u to the 3 divided by 3 plus the arbitrary constant, and u is arctan x, so we'll have a third arctan x cubed plus c, and that is our answer. Okay, even though you have a table of integrals, you can look up the integral of cosec squared x. Because we are dealing with u subs here, we're actually going to solve this, evaluate this the long way, right? So we are going to let u equal cot x, right? So u is cos x over sin x. Now we're going to use the quotient rule to get the derivative, right? We're going to look for du, so we're differentiating this function. cos we're going to call f, and sine x we're going to call g. So the derivative of this function will be f prime g minus g prime f over g squared. So f prime, the derivative of cos x, will be minus sine x. We multiply by g, which is sine x, minus g prime, the derivative of sine x will be cos x, times f, which is cos x. And that is all divided by g squared. So divided by sine squared x. And this is dx. So we will have minus sine squared x minus cos squared x over sine squared x dx. We can take out a minus now, and we're left with minus times sine squared plus cos squared over sine squared x, and then du equals sine squared plus cos squared is 1, so we have minus 1 over sine squared x dx. It's a bit messy. And du equals 1 over sine is cosec, so we have minus cosec squared x dx. So that'll be du. So here we are going to have the integral. Cot x we called u, so we're going to have root u times cosec squared x. Dx will be du divided by negative cosec squared x, so du over negative cosec squared x, and the cosec squared x terms will cancel out. So we have the integral of minus root u du. So we can pull out the minus, and we have minus the integral of root u du equals minus integral of u to the half du. So it's minus, we're going to add 1 to a half, so we have 3 over 2. So we have u to the 3 over 2. We divide by 3 over 2, which is the same as multiplying by 2/3, and then we add the arbitrary constant. So we have minus 2/3 u to the 3 over 2. Minus times arbitrary constant is another arbitrary constant. And u we called cot x. So it's cot x to the power of 3 over 2 plus c. Okay, again, you do have a table of integrals that you can look up all these functions. We're going to use the u-sub for sine h or sinh x. The derivative of sinh x is cos x or cos hx. That'll be dx. So that equals the integral of sinh x is u, so we're going to have u squared cos x, and dx is du over cos x. The cos x will cancel. And we have the integral of u squared du. That equals u to the 3 divided by 3 plus the arbitrary constant. And that equals a third times u is sinh x, and that's cubed plus c. So this one does look a little trickier than what we've already done. So with a little bit of manipulation, sine 2x is 2 sine x cos x. If we let u be cos x, then du equals minus sine x dx. And we can see we've got a sine x over here, right, in the numerator. So that's going to that's going to take care of the sine x then. So we have 2 sine x, and instead of cos x, we're going to write u over 1 plus cos x is u, so cos squared will be u squared. 1 plus u squared in the denominator times dx, which is du over minus sine x. So the sine x is now taken out. We have minus 2, which we're going to take out of the integral. And we're left with the integral of u over 1 plus u squared du. Now we can use another substitution. Whenever we see 1 over 1 plus u squared, right, we are going to use a trigonometric substitution. So we're going to let u be tan theta, du is then sec squared theta d theta. So we have minus 2 times the integral of u, which is tan theta, over 1 plus u squared. So 1 plus tan squared theta times du, which is sec squared theta d theta. So we have minus 2 times the integral of tan theta over 1 plus tan squared theta. 1 plus tan squared is a square identity, and that equals sec squared theta times sec squared theta d theta. Sec squared divided by sec squared is 1. So we have minus 2 times the integral of tan theta d theta. Okay, that equals minus 2 times the integral of tan theta is ln or ln sec theta, and then we add c. Bring the minus 2 in, so we have minus 2 ln sec theta plus c. Our substitution was u equals tan theta, so we need to express sec theta in terms of u, at least the first u, because we have another u up here, u equals cos x. So we'll draw a right angle triangle. Tan theta is opposite over adjacent, so it'll be u over 1, so opposite will be u, adjacent will be 1, and the hypotenuse will be root 1 plus u squared. So that equals minus 2 ln. Sec theta is hypotenuse over adjacent, so that's going to be root 1 plus u squared over 1, which is just root 1 plus u squared plus c. And we can actually remove the absolute value brackets here because 1 plus u squared is always positive. So we're just going to drop those absolute value brackets, and they'll be root 1 plus u squared plus c. Now this u over here must be expressed in terms of cos x, which was the first u substitution. So that's minus 2 ln root 1 plus u is cos x, so u squared will be cos squared x plus c. We can remove this root sign. It might be neater to do that, so we can write this as ln 1 plus cos squared x to the half plus c. And using log laws, we can bring this half to the front here and multiply it by minus 2. So minus 2 times half is minus 1, so it's minus ln 1 plus cos squared x plus c, and that is the final answer. We're going to let x be tan theta, so dx equals sec squared theta d theta. So we have the integral of 1 plus tan theta over 1 plus tan squared theta times dx, which is sec squared theta d theta. that equals the integral of 1 plus tan theta over sec squared theta times sec squared theta e to the sec squared theta cancels out, which is nice, and we get the integral of 1 plus tan theta d theta. You can split this up into two separate integrals. Might be not easier, but just neater to do that. So we have the integral of 1 d theta plus the integral of tan theta d theta. Integrating 1 with respect to theta is just going to be theta plus the integral of tan theta is ln sec theta, and we add the integration constant. Now we need to express theta in terms of a substitution, right? So just draw a triangle. The angle is x. Sorry, the angle is theta, and tan theta is x, right? Which is x over 1. So opposite over hypotenuse, and the opposite over adjacent rather, and the hypotenuse is root 1 plus x squared. So theta we're going to get directly from here. So if x equals tan theta, then arc tan x equals theta, or if you like, theta is 10 to the minus 1 x. So we have arc tan x plus ln sec theta. Sec is hypotenuse over adjacent. So it's root 1 plus x squared over 1. So you have root 1 plus x squared, and then plus the arbitrary constant. And that is the final answer. If you like, we can also write this as 10 to the minus 1x plus, if you want to, it might be neater to remove that square root sign. So we have ln, and we're going to drop the absolute value signs here because 1 plus x squared is a positive number regardless of the value of x. So we don't need the absolute value sign anymore. So we have 1 plus x squared, and the square root of that was taking 1 plus x squared and raising it to the power of a half. So we can then bring the half by log laws to the front of that. So it's a half ln 1 plus x squared plus c. So this is an alternative answer.